Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. On today's program, we're going to be talking about mass storage devices, disk drives, floppy disks, Winchesters, and some of the newest technologies for improving the mass storage of computer data. And we'll meet Alan Shugart, one of the pioneers in disk drive technology. Gary, we call a disk drive a peripheral, but really it seems to me of all the peripherals, a disk drive is really a key part of a computer system. There really aren't too many serious applications you can run on a computer without a disk drive.
Oh, yeah, that's absolutely true. The traditional model of a computer includes a backup storage device, a central processing unit, and main memory or central memory. And it was really the scaling down of those three components that really led to the microcomputer revolution in the first place. In the early 1970s, we already had semiconductor memory that was replacing core storage, and the companies that started to produce these microprocessor chips. And it really wasn't until a floppy disk came around that we had a complete computer system that could be used to do useful things, as you mentioned. It's interesting that the disk drive is really the only part of that, or the only component of that system where it's still mechanical. And it'll be interesting to talk to our experts today and see where they think it's going to go. Are we going to stick with mechanical storage, or is it going to become more semiconductor also?
Okay, before we meet our guests, we're going to take a brief look at the history of mass storage technology. Progress in the field of mass memory storage for computers has been directed by three basic needs: volume and density of information, and speed of access to that information. In the 1950s, computer data storage borrowed the recording technology being used by sound engineers, magnetic tape. Like its earliest predecessor, the wire recorder, oxide tape stored data sequentially. To reach information stored at the end of a reel meant running through everything stored on the tape up to that point. Short of faster tape drives, the only way to make data more accessible was to change the format of the recording medium. Disk storage, which allowed random access to information, was already under development in the mid-50s, but the popularity and potential of this technique became clear only in the last decade. The original 24-inch platters shrank to only 5 1/4 inches in diameter, while bit density increased 3,900 times, from a few thousand bits to almost 8 million bits per square inch. The improvements that led to that advance have today given way to new approaches that promise yet another dramatic increase in storage density. Thin film heads are smaller, more sensitive read-write heads made possible by technology developed in chip manufacturing. Because of their tinier components, they can read bits recorded much closer together on narrower tracks, about 12 million per square inch. Another development called perpendicular recording magnetizes the disk surface with vertically recorded pulses, data bits recorded on end instead of arranged horizontally. Once again, the effect is dramatic. This small change in the alignment of data means a 2- to 3-fold increase in storage capacity. Joining us now is Alan Shugart. He's one of the pioneers in the disk drive industry. Alan used to work with IBM, then he started his own company, Shugart Corporation, and then he started another company, Seagate. Alan, welcome to the Computer Chronicles.
Thank you.
Gary.
Alan, I don't know if you know this, but I got my very first disk drive from your previous company, Shugart Associates, and they gave it to me for free at the time. I probably don't do that anymore, do you?
No, I remember that. I remember that. I objected to giving away anything.
I think it was 10,000 hours on a test drive. It was. They gave me a new set of bearings to go with it, too. Do you think that the floppy disk drive was really instrumental in setting off the whole microcomputer revolution?
Oh, there's no doubt in my mind. The introduction of the 8-inch floppy really proved the technology, but the introduction of the 5 1/4 inch floppy really expanded the market and provided for the big explosion. No question at all.
We have these devices now that are called Winchester disks or hard disk drives, and they seem to be coming out of Seagate, of course, as a premier company in that area. How are the hard disk systems going to affect personal computing?
Well, I think what the hard disk system does is it's really complementary to the floppy, and what it's going to do is expand the capability of small desktop computers to do some very large jobs that require lots of storage. You don't see any small desktop computers with hard disk systems that also don't have a mini floppy in it also.
Mm-hmm. There's a way of getting data from one computer system to the other.
Absolutely, it's input, output, and backup.
One of the criticisms for using hard disks in small computers, when you move them around, people worry about reliability. What's your feeling on that? Is there a problem with transporting Winchester disks around?
Well, certainly a Winchester disk is much more susceptible to damage and from shock and vibration than a floppy, and that's because the media and the magnetic heads have to stay there all the time, and the heads are in contact with the media. And if you bounce it around too much, you could have some problems, where in the floppy you can take out the floppy diskette itself when you're transporting it. So the Winchester is much more delicate.
Is it something that's going to be, that problem going to be taken care of in the future?
Well, I think that they're getting better and better. I think that the newer versions are becoming much more shock resistant with stiffer air bearings and so forth. No, I think they're getting better.
Well, one of the things we have here is a 5 1/4-inch floppy disk drive, and this is fairly common, appears in the personal computers, and it has a lot of mechanical devices in it. There are little bales and heads that appear down here, and there's a board for decoding all the circuitry or the information that's coming through from the heads. And it seems to be a lot of mechanics in there, kind of the Model T of computing to some extent. Over here we have a bubble memory board this happens to be produced by Intel Corporation, and this is the bubble memory module itself. That's a 1 megabit chip. Now, some people would say that this type of device is going to be replaced eventually by a semiconductor memory device. What are your feelings about that, Al?
Well, I don't think it'll happen now. The floppy disk drive theoretically has an unlimited storage capacity because you can keep removing the diskette and putting a new diskette in. So it really has unlimited offline storage capacity, which the bubble memory doesn't have. So on a cost per bit basis, I don't think you're ever going to beat magnetic disk storage with semiconductor-like devices or bubble memories.
Al, you said the 5 1/4-inch disk was really the size that got the personal computer thing moving. That we see here a computer that uses a 3 1/2-inch, and here's a 3 1/2-inch micro floppy. Do you see this size as replacing the 5 1/4-inch format?
No, I don't. I think there's a marketplace for the smaller size, and I don't know if it will be the 3 1/2 or the 3 1/4 or the 3 or the 3 3/4. There seems to be lots of different formats vying for becoming the standard. There may be more than one standard, but I don't see that they'll ever replace the 5 1/4-inch mini floppy, because the world's programs are written on mini floppies, and you're never going to be able to, in your wildest imagination, transcribe all those programs onto smaller disks. It just isn't going to be done.
You know, it might be worthwhile just spending a minute talking about another technology that seems to be coming up these days, and that's one of video disks. Well, I happen to have one here on the table.
You're like a magician with you.
Yeah. And complete Beatles.
Really a video disc.
And it says here that if you pull these little things out, you get we just taught everybody how to get a video disc out. Now, this happens to be an RCA video disc, and it's a linear video disc. It's not built to be a random access device, at least it's the way it's recorded. And I think they say they can hold something like 10 gigabytes, is that right? Gigabyte, one gigabyte.
Very big number anyway.
And that's the equivalent of the Encyclopedia Britannica. Now, is there any application for this sort of thing in, say, personal computing and as a storage device?
I don't think so yet, except possibly for some archival storage. The problem with that kind of technology is one of error rate. Entertainment type recording for either audio or video, you can have a lot of errors and your eyes and your ears can't hear it. And the error rates associated with that kind of technology are several orders of magnitude less reliable than business computing requires. The disk drives, the data reliability of disk drives are several orders of magnitude better than you can get on that type of technology.
Now that's a non-optical video disc.
This
right?
happens to be called CED. That's RCA's version of a video disc.
Yeah. What about an optical device, a laser type disc? Is that more reliable?
Yeah, well, I think optical memory that you see advertised in the paper all the time now it's really for archival storage. You write it and then it stays the same forever. And I think that there's a place in computer systems for optical memory for archival storage. But my judgment, optical memory that has updating capability, like you can do with magnetic disk storage, is still in the laboratory curiosity stage.
How about, I've heard about perpendicular magnetic recording as a way of organizing the data on a disk so that you can get more volume, more density. Tell me what that is and where that's at.
Well, when you're storing data on a magnetic surface of a disk, what you're doing is you're flipping the little magnets that you can't really see, but there are little magnets in the disk that are lying on their sides, and you record something, you flip that magnet over, and then you can detect later on that you flipped that magnet. And there are only so many little magnets lying flat that you can get on the particular surface of a disk, and that's the recording density capability. If you could somehow get those little magnets standing on end, it's like a cord of wood. You can get more wood standing on end than you can lying flat. And if you could get them standing on end and then flip them and detect the flip, you can get more data storage in a given area than you can with them all lying down. And I think vertical recording is definitely in the cards.
With regard to the 5 1/4 inch mini floppy, again, one way you can get more on there is to use both sides of the disk, and there's some controversy about whether or not that's a good idea and whether a double-sided disk is as reliable. What's your view on that?
Well, I'm not sure if with what's available now, if it's more reliable or if it's less reliable or not, but there's no fundamental reason, I don't believe, why a double-sided shouldn't be just as reliable as a single-sided. I think perhaps some vendors in the industry stretched the technology farther than they should have and didn't do some other things, and as a result, a double-sided, double-track density floppy's got a bad name. And in some of those cases, they're probably not as reliable as a good old 48-track per inch single-sided, but there's no fundamental technical reason why they shouldn't be just as reliable.
From a user's point of view, is there a big difference in the quality of a mini floppy disk that you buy?
Gee, I don't know. I don't buy very many.
But I mean, in the technology of manufacturing the medium itself, I mean, you know, there are different price ranges and so on. And from a user's point of view, are they all the same or they're not all the same?
I really couldn't tell you. I'm sure Gary's more familiar with that than I am, but I don't use very many floppies, and so I really couldn't tell you.
Gary, could you tell?
Well, I haven't had any particular trouble with any media that I've run across over the years. I've found an inherent reliability in just about all these. I think, as Al mentioned, it's mainly based on the kind of electronics that people are putting into these machines.
Okay, gentlemen, and we're going to take a short break. In just a moment, we're going to be joined by a man from Memorex, and you'll be able to decide for yourself whether he's here live or on tape. Okay, joining us now is Frank Sordello of Memorex. Frank is the Corporate Vice President for Technology there. Like Alan Shugart, Frank was with IBM way back when, I believe. And also, Frank is the holder of 38 patents in magnetic recording and disk technology. Gary, you want to start?
Well, with a background like that, I'm sure you can give us a pretty good idea of what's going on. Frank, you've got a number of different kinds of platters here. Can you tell us a little bit about what you've got?
Certainly. The platter with the thick substrate that we see right here is our latest product platter of a 14-inch diameter. For the Memorex Corporation, it's the 3680 1.2 gigabyte per spindle disk file platter.
Could you pick it up, perhaps, Frank? We get a picture of what you're talking about.
Certainly. The key items with the latest high-performance disk file technology consist of the adjectives thick and thin. Thick substrate, that is the thickness of the aluminum substrate, and thin film heads that go with it. With that, we are able to store that capacity that I mentioned, which is equivalent to all of the words and letters in 4 complete sets of Encyclopedia, Britannica, Americana, Book of Knowledge, and perhaps even the Funk and Wagnalls.
On that one platter?
No, on 9 platters and 1
stacked.
spindle in the device.
And then what else do we have here?
Well, this is a thinner substrate, 75 milli-inch aluminum substrate, 8-inch disc platter that's used in some of the smaller products of the day. And these are the 5 1/4-inch disc platters that are used in the so-called Winchester mini drives.
This is what we're talking about here.
Yes, that's a particulate oxide, just as these platters are. These are thin film platters, which is the next generation of platters.
Now, you mentioned, Frank, thick medium here and thin film head technology. Tell us what that is exactly.
All right, the heads are essentially a bent nail with wires wrapped around them. The technology consists in the size of the bent nail. In order to lay down 15,000 bits per inch along the circumference of the platter, the size of the nail, the equivalent quote around the nail, has to be very, very small. Currently, ferrite head products, and currently in the past 8 years, have been made by lapping and grinding and machining of the geometric dimensions of the so-called quote nail unquote. The semiconductor industry has taught us how to put a computer on a chip using photolithography and deposition techniques, thin film deposition techniques. Therefore, the thin film head technology consists of manufacturing the equivalent of the bent nail utilizing photolithography to get dimensions that are in the millionths of an inch and repeatability and bulk mass production.
Is that that's a thin film head over there? Maybe you could show us what that looks like.
Yes. This is the 3680's thin film magnetic recording head arm assembly. There's 4 heads on the end. The top 2 service the bottom surface of the top disk. The bottom 2 service the top surface of the bottom disk. These heads consist of an air-bearing slider which has a pair of wings or skis, and on the rear, very difficult to see but can be seen in microphotographs, are thin film elements that have been deposited. These devices are able to record 12.5 million bits for every square inch of disk surface.
Frank, do you feel like you're going to reach any kind of mechanical limitations here at some point, or are you going to be able to just keep getting this dense, more dense, more dense?
Well, we have projected in our strategic plans what the limitations are. There are 3 key measurements in any disk file product. They consist of the number of tracks per inch along the radius of the disk. The second one is the number of bits per inch around the circumference of the disk. And the third key parameter is the product of the 2, the tracks per inch times the bits per inch. On the present products that are mass-produced with thin film heads and advanced particulate media, we have 800 tracks per inch, 15,200 bits per inch, and the product comes out 12.5 million bits per square inch. Through additional thin film heads and thin film media that will be making its debut shortly, that areal density will change by a factor of 16 times. We have the principles by which we can increase the areal density by 16 times to in the order of 200 million bits per square inch.
What's the cost factor involved in this thin head technology?
Well, if we look at the recording head, it consists of 2 parts. The air-bearing slider, which is the larger part that you see, and then the magnetic transducer, what I called the bent nail earlier, part that's on the rear. If we compare it to the Winchester ferrite heads of today's mass production and older technologies, we find that the air-bearing slider cost is about the same. The transducer will eventually have a lower cost, just as vacuum tubes cost less than solid-state devices. The factor for product cost 5-6 years from now will be in the order of 3 to 5% less, but not significantly less. However, if you tried to manufacture a ferrite head to perform at the capability of the thin film head, then the cost picture would be overturned.
When we're talking about thin film head technology, that only relates to Winchester's hard disks, or does that have application to floppies?
It has application to all magnetic recording. The thin film materials, which lend themselves so well for magnetic recording, are relatively soft, and therefore they have a wear problem. The rigid discs have the air-bearing sliders, which allow the heads to fly at 13 to 15 millionths of an inch above the surface. Hence, there is no wear. Hence, thin film heads make their debut there first. When the wear problem is resolved, thin film heads will find its way through floppies, tape drives, all magnetic recording.
To try to appreciate that distance, I think you have an analogy about an airplane, don't you, to help us understand that?
Yes, it's a classic one. The products of 8 years ago, the flying height was 20 millionths of an inch, would be the equivalent of a 747 flying at 590 miles an hour, 1/8 of an inch above the Earth's surface. The products that are exhibited here, flying at 13 microinch, that dimension is closer to 1/16 of an inch above the Earth's surface.
Alan, from your perspective and your end of the business, is this a major factor in what you're doing?
Currently, right now, it's not, because the recording densities that we have that we're required in our products don't need that kind of technology. At some point in the future, we would expect thin film heads to be used in our small, very cost-sensitive products also.
It's interesting to note that this is a 1.2 gigabytes per spindle, which is, if we get back to our original discussion about video discs, this is just about the same size as that video disc, roughly. And there's been a lot of discussion in the industry about how you do some simulation of video discs, and maybe this part of the answer is in your 1.2 gigabytes per spindle.
Real quickly, we just have very little time left. This is something I thought worth looking at. This is a laser card, which we just got to look at, which apparently has 2 megabytes of information on this. Frank, do you see optical storage devices as replacing in any way magnetic storage devices?
Yes, when one thing occurs. When the erasable, real-time erasable, just as magnetic recording is real-time erasable, optical media makes its debut, then I believe we will see the exponential decay in time of magnetic recording. Optical recording gives us the promise of over 2 billion bits per square inch. The first non-erasable optical devices are in the range of 1/4 billion, that is 250 million to 500 million bits per square inch already.
Frank, I have to interrupt because we're out of time. Frank Serdello of Memorex and Alan Shugart of Seagate, thanks very much for being with us, and I hope you'll join us next week on another edition of the Computer Chronicles.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.